Hi guys, today's topic is writing and graphing inequalities. An inequality is a mathematical sentence that compares expressions, and an inequality statement is going to have one of four symbols in it. The less than symbol, the greater than symbol, the less than or equal to symbol, or the greater than or equal to symbol. A solution of an inequality is a value that makes that inequality statement true. The solution set is all of the solutions that make that inequality statement true. And the graph of an inequality is actually all of the numbers in the solution set graphed on a number line. One key concept to understand when you're working with inequalities is to know what these four symbols actually stand for. So we have the less than symbol, which can also be read is fewer than, the greater than symbol, which can also be read is more than, the less than or equal to symbol, which can also be read is as most or is no more than, and the greater than or equal to symbol, which sometimes also is read is at least or is no less than. So when we have a statement written out in words, we can change this statement into an inequality statement. A number w minus 3 5/10 is less than or equal to -2. I'm looking for some key words here that tell me which inequality symbol to use in my inequality statement. And I see is less than or equal to, which basically tells me that I'm going to be using this symbol right here, less than or equal to. So they said a number w minus 3.5, so w minus 3.5 is going to be less than or equal to -2. And there is my inequality statement. Let's try another one. -7/10 is at least twice a number k minus 4. So -7/10 is what I'm starting with. Then I see some keywords, is at least. So here's my keywords, which tells me I'm going to use this symbol right here, the greater than or equal to symbol. So -7/10 is at least twice the number k minus 4. And there's our inequality statement. Here I'm being asked to tell whether -4 is an actual solution to these inequalities. So the first inequality that I'm going to test is x plus 8 is less than -3. So in place of x, I'm putting in -4. So I have -4 plus 8 is less than -3. And when I solve -4 plus 8, I get 4. 4 is not less than -3. And therefore, in this case, -4 is not a solution of this inequality because this final statement right here is not true. If I look at this inequality, -4 5/10 times x is greater than -21, and I plug in -4, -4 5/10 times -4 gives me positive 18, and 18 is greater than -21. So in this case, -4 does work as a solution because this final inequality here is true. When we're graphing solution sets for inequalities, we have to keep a couple key ideas in mind. We're going to use an open circle when we're graphing on the number line and the number we're graphing is not part of the solution, a closed circle when the number we're graphing is part of the solution, and an arrow that goes to the left or the right to highlight all other solutions for the inequality. So let's start with this guy. Y is less than or equal to -3. So I'm comparing y to -3. So I'm going to have to make a circle on the number line at -3. In this case, I'm going to close that circle in. I'm going to do the closed circle because -3 itself could be a solution to this inequality. It is true to say -3 is less than or equal to -3. The less than part isn't true, but the equals part is. So I'm going to fill in this circle. Now I have to decide which side of this number line represents the rest of the solutions. Would -2 make this statement true? Would -4 make this statement true? Actually, it's -4, -5, those smaller values that are going to make this statement true. So what I'll actually do is I'll use my marker here to highlight these guys, to make that part of the number line stand out, because those are my solutions. So let's take a look at this guy. We're comparing x to 2. So at 2, I make my circle. In this case, 2 is not a solution, because we wouldn't say 2 is less than 2. Doesn't work. There's no equals there, so 2 is not a solution. I keep my circle open. I'm looking for other solutions that would make this true. And in this case, it's the numbers on the right side. 2 would be less than 3, 2 would be less than 4. So I'm going to highlight the number line in this direction to draw attention to those other solutions. Here I have x is greater than 0. So at 0, I'm putting my circle. I would not fill the circle in because 0 itself cannot be a solution to this inequality. Looking for numbers that make this statement true. Would it be these smaller numbers or these bigger numbers? I can plug some in. -2 is not greater than 0, but 2 is greater than 0. So I'm going to highlight and draw attention to these numbers going to the right here. This time we actually have some graphs that are showing height restrictions in inches for 2 rides at an amusement park. And we're being asked here to write an inequality that's going to represent these height restrictions for each ride. So on ride A, I see that I have a circle here at 48. And I also see that that circle is filled in, which tells me that somebody who is exactly 48 inches can ride this ride. So I'm going to call the person's height H. And I know that they could be equal to 48 inches. I also see that the numbers to the right are highlighted. So in order to ride this ride, you have to be bigger than 48 inches or exactly 48 inches. So the height needs to be greater than or equal to 48. For this ride, I see my circle is at 52. So the height is being compared to 52. But this time, if you're exactly 52 inches, you're not allowed to ride because the circle is open. 52 is not a solution for this inequality. I have to be less than 52. So in this case, these heights have to be less than 52 inches in order to ride the ride.